I would like to discuss the general rules by which we can judge the likelihood of a cryptid existing, aside from empirical evidence. 1. The cryptid must follow the laws of physics. While the general natural laws of biology can be bent a bit, the laws of physics cannot. A creature cannot create its body mass out of nothing, get free energy, or be a perpetual motion animal. They cannot beat the square cube law, entropy, or thermodynamics. 2. The cryptid must be sensibly linked to the existing taxonomy. While some missing links between the supposed cryptid species and their plausible genus can be allowed, the species cannot be completely impossible to be placed in a family or suborder. If the order or class cannot be determined, it's not a cryptid, it's an alien, and if the phylum or kingdom cannot be determined, it's probably not a living creature in the first place. 3. The cryptid cannot be an ancient species or genus. While not impossible, it's very implausible that a species would survive for millions of years unchanged, while simultaneously living in an environment where humans can encounter it often enough for it to gain cryptid status. So, for example, a living deep-sea coelacanth species that barely changed for the last 65 million years is a fact, but a species of land-based dinosaur could not have remained unchanged since then, as their environment changed entirely several times, over which would enforce evolution or cause their extinction. Arguably, a cryptid could be an atavistic evolutionary throwback like, say, a bird, evolving to look like a velociraptor again, but it's extremely improbable. 4. The cryptid cannot be an R-selected explosive breeder of any kind, or we would have found and proven it by now. R-selected breeders produce a lot of offspring to dominate their environment, and the offspring either fill the eco-niche entirely, or is severely culled by the survival of the fittest. Such species are almost impossible to miss. They are only cryptids in that their exact species is not separated in the taxonomy due to the abundance of subspecies of their kind. Like, say, a 425th subspecies of shrimp is a cryptid for shrimpologists for a while, but just a regular animal to most people. Just because there is a debate whether yet another shrimp species exists or not does not make it a cryptid, and the elusive slightly different finch that one ornithologist saw once is only a cryptid on technicality. 5. The cryptid cannot be low in the food chain, or if it is, it cannot be a major link. By definition, cryptids are rare, and if they were at the bottom of the food chain, then their predators would be even rarer, and their predators rarer still, until the apex predator species would be too small in numbers to survive in breeding. Thus, the higher an animal is in the food chain, the greater the likelihood of it being elusive enough to gain cryptid status X. If there was a species of bear that predominantly hunted Sasquatches as its main diet, it would be even more of a cryptid than Bigfoot. 6. The cryptid needs to be a specialized niche species, not a universal adaptive generalist species. There are unlikely to be any cryptid cockroaches, ants, rats, mice, rabbits, or catfish anglers, because if there were, they would break out of cryptid status by spreading all over the world and becoming widely known. Hence why the giant squid exists and used to be a cryptid. Giant squids are ubiquitous, but only in their specific niche of oceanic depths, but a universal adaptive generalist cephalopod like an octopus cannot grow the same size, seeing how we are not encountering a kraken any time we visit the beach. 7. The cryptid must be a relatively long-lived species for its genus and family. The whole reason cryptids are cryptic is that they can exist as tiny, stable populations for a very, very long time, inhabiting a tiny and remote niche that humans seldom explore. But if the cryptid were a short-lived animal that achieves bleep maturity and breeds quickly, then it would eventually evolve out of its niche or go extinct due to compounded mutations from all the passing generations. If a corollary to the points above, the cryptid must be a species relatively immune to inbreeding depression, since it would, by definition, breed within a tiny population. For example, the likelihood of the Bigfoot existing is greatly reduced by the fact that it would need to have a close-knit population of at least 1,000 individuals to avoid extinction by bleep, and if we assume Bigfoot predated the arrival of bleep sapiens in America, they would need a population of 5,000 to stand any chance. This alone disproves Bigfoot, since rather than a solitary, rare and elusive powerful beast, it would be a whole town's worth of misshapen Habsburg-looking mofos. In general, this problem makes mammalian cryptids significantly less likely to be real. 9. The cryptid must have little environmental footprint. It cannot drop turds everywhere, or die in the open and leave a sus skeleton for humans to find. It cannot leave easily identifiable footprints, tufts of fur, claw marks, or mark its territory. It cannot build nests, burrows, or other kinds of shelter. It cannot be an intensive hunter or grazer that would scour their habitat clean, or we would have found the evidence long ago. Finally, the cryptid must be relatively intelligent for its family, let alone its genus. There is only so much a niche environment or sharp instincts can help a creature avoid being detected by humans. It needs to be smart enough to specifically recognize humans as a threat, not just react instinctively to our sight, noise, or smell. So, what we are looking for is a peculiarly robust apex predator/omnivore, perfectly fit for a niche that had not changed for hundreds of thousands of years at least, that exists on the very edge of starvation without losing metabolic efficiency, lives for a long time, breeds late, and very rarely is much smarter than we could expect, definitely sentient, possibly sapient, and is strongly resistant to the detrimental effects of genetic mutations, not just the ones that come from inbreeding, but also the ones caused by viruses, parasites, cancerogens, etc.